final project about a pressurized water reactor presented by Ville and Tam Nguyen. The picture illustrates one of the PWR reactors in the world. Among nuclear reactors, PWR are the most common type in use today because of 67% of these reactors are found worldwide. They also account for 80% of Europe's installation and 100% of France's nuclear reactors. In the US, it was operated by the US Army Nuclear Power Program from 1954 to 1974, and Three Mile Island Nuclear Generating Station, as known as TM1 and TM2, were part of those reactors. So now let's talk about the process of PWR. The process of creating electricity using nuclear power begins with the splitting of uranium atoms in the reactor core. This process called fission produces heat in the pressurized water reactor. The heat from water surrounding the nuclear fuel is kept under pressure to prevent it from boiling. The hot water is piped from the reactor vessel to a steam generator where it transfers its heat to boil water and make a steam in the second system. After transferring its energy, the water is pumped back to the reactor vessel to be reused through the primary loop, and the non-radioactive steam from the steam generator flows through the secondary loop and spin turbine that supply the generator to produce electricity. After the steam is used in the turbine, it is drawn into the condenser where it is connected to the cooling tower and condensed back into the water and pumped back to the steam generator to be heated and reused. The main purpose of coolant is removing heat and maintaining temperature below 705 degrees Fahrenheit, around 374 degrees Celsius. In this reactor, like water is used as the primary coolant in the PWR, the pump provides a forced primary loop to remove the heat being generated by the fission process. The horsepower rating will be from 6,000 to 10,000 horsepower to provide a necessary flow of coolant for heat removal, approximately like 100,000 gallons per minute per pump. Next, the pressurizer is controlled by the use of electrical heaters, pressurizer spray, power operated relief valves, and safety valves. It operates with a mixture of steam and water in equilibrium and contains water with a nitrogen atmosphere to prevent it from existing in a potentially explosive environment. The uranium enriched to 3.5% or including plutonium MOX is the fuel of PWR. A metallic roll of Zigaroid surrounds the element. This first barrier traps the radioactive products that are formed within the pellet. A fuel assembly of the nuclear reactor core consists of an array of fuel roll and control roll guide thimble bunched together held with the grids. The fuel roll is made from the zirconium alloy lead tubes containing cylindrical fuel pellet made from synthetic UO2. The PWR uses enriched uranium fuel with a slightly higher enrichment level than the PWR. This is responsible for the higher power density with the reactor core. And Ville will present it for the next slide.
So, PWR had advantages over the other live water reactor and earlier generation nuclear sites. One of major advantage of this reactor is that it is easy to operate because less power being produced as the heat increase. The core of reactor contains less fission material, decreasing the chance of additional fission events to occur, and the PWR can operate at higher pressure and temperatures around 160 atm and 315 Celsius degrees. And lastly, the most advantageous element of PWR is the turbine cycle because the primary and secondary loops are separate, so water can never be contaminated by any radioactive material in the main system loop. Majority of Western nuclear plants, and it is the reactor choice for the most Navy nuclear propulsion system. There are some notable disadvantages to using such as a reactor. For one thing, the reactor requires very strong piping and a heavy pressure vessel in order to ensure that the highly pressurized water remain at liquid state and when sustained in high temperatures, making the construction of the PWR costly. Meanwhile, most reactors need to be refilled after about 18 months and it cannot be refilled while the reactor is running. So because the refilling process takes few weeks, so the reactor must go offline for this time. And lastly, unknown water contamination in the main cycle exists. Boric acid, which is corrosive to carbon steel, can get melted into the coolant, causing the radioactive products to circulate throughout the loop. These radioactive you are disrupted to the reactor. Okay, so in the PWR, the water passes over the reactor core to act as moderator and coolant do not flow to the turbine, and it is contained in a pressurized primary loop. The primary the primary loop water produces steam in a secondary loop which fires to the turbine. And the obvious advantage to this is that even the fuel in the core was not pass any radioactive contaminant to the turbine and condenser. So the conclusion would be the PWR reactor commonly used in a nuclear power plant over the world. The reactor converts heat and that it generates into fuel into the electrical power. The power can be used for industrial and residential purposes. The leftover water in the main condenser is recycled back to the steam generator. Under the reactor has some disadvantages. It makes up for its deficits in the fact that that would be a safe and reliable reactor. So here are reference and thank you for your listening.